Yet another, number 4, overly simplified, very fast review of material covered in class. We're going to talk about the renin-angiotensin pathway. Back over here, we were talking about the idea about the juxtaglomerular apparatus being able to help regulate overall body blood pressure, while it's also trying to take care of the blood pressure inside the glomerulus. The way that it influences your entire body is by the production of renin, R-E-N-I-N. So here is that story. You remember that your liver makes angiotensinogen. And of course, ogen at the end of a word implies that this is an inactive form of something in the front, angiotensin. The word angiotensin literally means here's a vessel and here's pressure. So this is an inactive plasma protein that can cause an increase in blood pressure if activated. If the blood pressure heading towards your kidney goes down, the juxtaglomerular apparatus can recognize this at the level of the nephrons and produce renin. The renin can convert angiotensinogen in your blood plasma, into angiotensin 1. Angiotensin 1 moves throughout your body, and as it goes to the lungs, it can be converted into angiotensin 2. And as angiotensin 2, it is a very strong vasoconstrictor. So angiotensin 2 in reaction to blood vessels causes increased vasoconstriction. Increased vasoconstriction will cause increased blood pressure, and you solved your original problem. Blood pressure was low. Through angiotensin 2 and vasoconstriction, you increase the blood pressure. But another way in which angiotensin 2 can help increase, in this case right here, the blood pressure is by stimulating the adrenal cortex to produce aldosterone. This is just one of the many stimuli that can cause aldosterone release or production. But under the influence of angiotensin 2, aldosterone will cause the nephrons to increase their reabsorption of sodium. With increased sodium reabsorption into the blood, it, in essence, draws water to it. And then you have increased water reabsorption into the blood. That's going to increase the volume of the blood, and that will increase the blood pressure, and again, you solve that blood pressure problem. Over here, angiotensin 2 can also stimulate the hypothalamus to release antidiuretic hormone, ADH. ADH will directly stimulate the tubular reabsorption of water. By saving the water from the urine and putting it back inside the blood, you've increased the blood volume, and again, you increase the blood pressure. Now, the use of aldosterone and ADH to reclaim that water is called facultative water reabsorption. Down here, real quickly, we notice that the places where you find reabsorption, proximal convoluted tubule, distal convoluted tubule, two very common sites. With obligatory water reabsorption, it's genetically programmed. You're going to get it because it's genetically programmed. However, with facultative water reabsorption, it's the presence of the hormones that determines whether you're going to get this extra water back or not.